Welcome to the deep dive. Today we're going to examine the technical foundation of high-end meeting room technology,
And for our case study, we're looking at a classic piece of hardware.
the Kramer VIA-CAMPUS2. Now, this specific device is discontinued, but its architecture is, well, it's a perfect blueprint for understanding the raw power you need for seamless wireless collaboration.
Exactly. We're diving past the simple marketing stuff, screen mirroring, and we're getting into the intense technical backbone.
So our mission today is to really connect the dots between the processor, the networking, and the software to show why a device like this just couldn't compromise on hardware.
Okay, so let's start with the basics. What was this thing for?
Right. What's the collaboration environment we're even talking about here?
Its core purpose was to facilitate actual work. It wasn't just a passive display interface.
I mean, it was a real-time digital workspace.
Yes. Users could view, edit, and comment on shared documents all at the same time. And the system could even record the whole session.
So you're moving beyond just casting into a fully integrated digital meeting. And versatility was obviously key.
Oh, completely. It had to be compatible across the board.
It supported all the major protocols, right? You had iOS with AirPlay, Windows, and Android using Miracast, and even Chromebook mirroring.
And the user capacity is where the architecture really got stressed.
Let's talk about that. On a single main display.
It was engineered to project up to 6 different user screens at once.
And 6 screens. And if you had a dual display setup, that jumped to 12 active feeds.
12. And crucially, you could also pull that main display back onto your own personal device, so everyone was connected to the central chaos.
That's a really heavy feature list.
Yeah.
I mean, 6 or 12 simultaneous video streams plus real-time document editing. What kind of processing tasks does that put on a machine?
It's immense. Think of it like a traffic controller, but for 6 to 12 lanes of high-speed video.
So each stream needs encoding, network prioritization.
Security management, and then immediate decoding for the display, all in parallel. That's why it needed such serious video muscle, including support for 4K at 60 frames per second.
And for anyone looking at the physical ports, the I/O confirms that it had a standard 4K at 30 Hz HDMI output, but also that higher spec 4K at 60 Hz DisplayPort.
And that 60 Hz capability is crucial. It means you get true motion clarity, for detailed spreadsheets or fast-moving CAD drawings.
So wait, let's dig into the internals that made that possible.
Yeah.
It ran on a 3.60 gigahertz quad-core processor, an 8th generation chip.
And it was supported by 8 GB of DDR4 RAM and 128 GHz solid-state drive.
That sounds like a full desktop computer, not a screen sharing box. Why couldn't they just use, like, a high-end mobile chip?
Because it wasn't a mobile task. It was, like you said, the equivalent of running 6 continuous 4K media players, a security system, and a full OS all at once.
A mobile chip just can't handle that kind of sustained I/O.
Not at all. And that 8 GB of high-speed RAM was essential for buffer management, making sure the system didn't stutter when multiple people started working at once.
And the wireless, that Intel dual-band 802.11ac, that wasn't just about fast file transfers, was it?
No, it was about managing density. The density of traffic, you have up to 12 devices, all trying to multicast data in the same room. It's about minimizing that latency.
So this powerful hardware was also key for integrating with, modern workflows.
Of course, it wasn't a closed system. It fully supported third-party apps like Microsoft Office, Teams, Zoom, WebEx, all the big players.
It even had some really specialized networking features.
Right, like seamless live video streaming using RTMP, which is the standard for low-latency streaming directly to platforms like YouTube or Kaltura.
So when you look at the whole package, it was comprehensive. Room calendar integration, digital signage.
And baked-in cloud file sharing for iCloud, Dropbox, Google Drive. It was built to be the center of everything.
Which raises a really important question for you, the listener.
This device, the VIA-CAMPUS2, just to manage sophisticated wireless screen sharing, needed an 8th gen quad-core processor and 8 gigs of RAM.
The horsepower of a full, capable desktop PC.
So, if simple real-time collaboration requires that kind of dedicated processing, what trade-offs in capability and speed are we accepting in the smaller, more cost-efficient devices we rely on every single day?
Think about that complexity the next time your screen share starts to lag.